Assalamu alaikum. Hope you are doing fine. When a positive charge is brought near another positive charge, there exists a force of repulsion between these two charges. We know the work done to bring a unit positive charge from infinity to a point against the force of repulsion is referred as electric potential. In this video, we are going to get the expression for electric potential at a point due to an electric dipole. For that, I consider an electric dipole which is made of a negative charge minus q placed at a point A and a positive charge plus q placed at point B. Here these two charges are separated by a small distance 2b. The distance between them is 2b. Now as a whole, this arrangement constitutes an electric dipole. This electric dipole have a midpoint repellable letter O. The distance of O from A is taken as small a. In the similar way, the distance between O and B is again taken as small a. So the total distance between A and B is nothing but 2a. Now I'll take a point P, a distance r from O. A distance r from O, I take a point P, where I am going to find out the electric potential due to this electric dipole. Let's do that. Now I'll connect this point to A. Point P is connected to A. Similarly, point B is also connected to point P. Now, what is the distance between O and P? It is taken as R, and the distance between B and P is taken as R1. The distance between A and P is taken as R2. Then the angle between OB and OP is taken as theta. If it is so, then what will be the angle between OP and OA? This can be obtained if we subtract the theta from the total angle. Now, here the total angle is 180 degree. If I subtract theta from 180 degree, what do I get? I get this 180 minus theta. This is the angle between OP and OA. Now I find out the electric potential at point P due to positive charge. What I write here, I take it as V plus. This represents the electric potential at point P due to positive charge, and it is found to be equal to 1 upon 4 pi epsilon naught. Then Q plus Q actually divided by the distance between them. What is that? It is R1. This is the taken as equation 1, and it represents the electric potential at point P due to plus Q charge. Then I get the electric potential at point P due to negative charge. It is written as V minus. Okay, and that is found to be 1 by 4 pi epsilon naught. Here we have minus Q upon R2 is the distance. Okay, so this can be written as minus 1 upon 4 pi epsilon naught Q upon R2. This is question number 2. We have obtained the electric potential point P due to positive charge and negative charge separately. Now I will find out the total electric potential at point Q due to this electric dipole. Let's do that. Now for this, I take the total potential. Write it here. Total electric potential. Total electric potential. Electric potential at P is given as V. So V equals to the sum of these two, V plus added with the V minus. We know the value of V plus and V minus. I substitute on here. So what I'll get? I'll get this 1 upon 4 pi epsilon naught Q upon R1. This stands for V plus. Then it is added with equation number 2. Minus 1 upon 4 pi epsilon naught Q upon R2. This is the total electric potential at point P due to the electric dipole. Now after that, I simplify this. V equals to, what is common here? The common term is Q upon 4 pi epsilon naught. It's the common term. I read it like this. 1 upon 4 pi epsilon naught multiplied with Q. Then inside what is left? 1 upon R1, and here plus into minus becomes minus 1 upon R2. This is taken as equation number 3, and this provides us the total electric potential at point P due to the electric dipole. Now let's go ahead. Now if I substitute the value of R1 and R2 in this expression, then the final expression for V will be obtained. Now how to do that? To get the value of R1 and R2, I use cosine law. Now applying cosine law. What? The cos law, the cosine law is applied to a triangle. First I take a triangle BOP. Applying to triangle BOP. What is this? I draw this triangle here. Okay. This is P. This P, this is a B, and this is a O. Let's take it this way. Then the distance between O and B is a from the diagram. The distance between B and P is nothing but R1. Now from the diagram, the distance between O and P is small r. Okay. Now look at this carefully. How I am going to apply cosine law to this triangle. What I do? I square this. The angle here is theta. Okay. I take opposite angle to this opposite side to this angle. There's nothing but r1. I square this. After squaring this, it will be equal to the square of remaining sides, that is r square plus a square. Then this is subtracted from this value. So I write 2, then I write this 2 RA cos of angle between OB and OP. What is that? Theta. It's written here. Okay. Then after that, I do small changes to this. I take r square common. If I do so, what remains here is this 1. 1 into r square is r square. This is what we obtained. So 1 plus a square divided by r square. Now if you multiply r square with this, you will get a square. Clear? Then minus. You see what I do? I write this 2a cos theta divided by r. Okay. Now if you multiply this two part, you will get this. This is what we have obtained. After that, if you look at the diagram, it is clear that the value of a is very much smaller than r. What is so? Right here, a is very small compared to r. So a square upon r square is neglected. Here a is very small. After squaring that and divided by r square, the value that we get is too small. By adding that value to this part, it's not going to make a big difference. It is something like suppose I add 1 glass of water to the water present in ocean. Then if I write that the volume of water present in ocean plus 1 glass of water, then it is completely meaningless. So adding a square upon r square to this part is something like that. Adding 1 glass of water to the water present in ocean. It is not going to make any big difference. So a square upon r square is very small value, so it is neglected. Then this expression will appear something like this. R square, r1 square is equal to r square to 1 minus 2a cos theta upon r. Then this can be written as, now I take a root both sides. So what I will get? R1 square will become R1 after taking square root. Okay, I write here for better understanding. Taking square root. What do we get? We get this. R1 square will become R1 and R square will become R. Then this part will be written like this: 1 minus 2a cos theta upon R power half. We know root of a value, because if you have root of x, then this can be written as x power half. This is what we have done here. Okay. After that, I take reciprocal of this. We apply the value of R1. Now to make my work more easy, I take a 1 upon R1. So reciprocal of R1 is nothing but this. 1 upon R1 equals to, no, we take a reciprocal for each term. R will become 1 upon R, then this term will become 1 minus 2a cos theta upon R. Now power half will become power 1 by power minus half. Clear? So here we have obtained the expression for 1 upon R1. I take this one as equation number 4. Okay. Now I need to get the expression for 1 upon R2. After doing so, if I substitute the value of 1 by R1 and 1 upon R2 in equation number 3, then easily I get the value of the expression of V. This is what I am going to do. See, to get the value of 1 upon R2, I am going to apply cosine law to this triangle AOP. So apply cosine law to triangle AOP. What is this triangle? See, triangle is this. This is A, this is O, this is P. Okay, the distance between both is nothing but R from the diagram, R, and the distance between AP is R2, this is mentioned here, and the distance between OA is small a. Okay, now I am going to follow the same method here to get to the value of 1 upon R2. So I do here, apply. Here the angle is 1 theta, sorry, 180 upon theta. 180 upon theta. This is the angle between OP and OA. So this is the opposite side to the angle mentioned here. So I start with that. I square the opposite side. R2 square is equal to the sum of square of these two sides. R square plus A square minus 2 into AR. Then cos of the angle. The angle is 180 minus a theta. Now here, look at this carefully. What is the value of 180? Here, cos of 180 minus theta is nothing but minus a cos theta. That I am going to mention here. By doing so, I get this in the next step. R2 square equals to R square plus A square minus 2AR multiplied with minus a cos theta according to this. So when these two get multiplied, we get the value R2 square equals to R square plus A square minus multiplied with minus become plus 2AR cos theta. Okay, now if you look at this, it appears somewhat equal to this one. Now, I follow the same method. I take a r square common outside. This taken out. What I get? Comes r square upon r square. So it is 1. Then, okay, I do one thing. Increase one step here to make you understand in a better way. Okay, fine. There is a 1 here plus a square upon r plus 2a cos theta divided by r. Okay. If you multiply each term with r square, you will get the terms present in the previous step. Clear? Then after that, I take square root. Taking square root, if I take square root, r2 square will become r2. Then r square will become r, then this term. Now, I do two things. I neglect this part. It's r square. This part is neglected, then square root is taken. Here, I write that. Since a is very small compared to r, so a square upon r square is neglected. If I neglect that and I take square root, what do I get? I get this 1 plus 2a cos theta upon r. No, this is what I have done. Okay, let me increase one step for better understanding. Take a square root now. Take r2 equals to r 1 plus 2a cos theta upon r power half. This is the value of r2. Then from this 1 upon r2 value can be obtained by following the same method, by taking the reciprocal. I will do that. Now I take the reciprocal of this expression. r2 is written as 1 upon r2. The same change is made to this part of the equation. R is written as 1 upon r. Then 1 plus 2a cos theta upon r. Now power half, instead of power half, I write power minus half. I name this equation as equation number 5. Now before that, I box this equation for convenience. This is equation number 5. Now, if you observe equation number 5, equation number 4 and 5, you find a upon r value here. A upon r value is very small compared to 1. So, I use a binomial theorem on these two equations for further simplification. So, binomial theorem is used. when I use the binomial theorem, I neglect higher terms here. Okay. So equation 4 will become something like this. 1 upon R1 equals 1 upon R. See what is done here? This term is multiplied with the power. 1 is kept as such, then this term is multiplied with the power. 2a cos theta upon R. It is multiplied with the power. What do you have there? Minus half. We get this term. Get is equal to 1 upon R1 is equal to 1 minus multiplied with this becomes plus 1 plus, and here this 2 and this 2 will cancel, and what remains is this a cos theta upon R. This is the value of what? 1 upon R. This is 1 upon R value. Okay. So 1 upon R is actually 1 divided by R. 1 upon R1 is equal to 1 divided by R multiplied with 1 plus a cos theta divided by R. I box this for my convenience. This provides me the value of 1 upon R1. This is taken as equation number 6. Okay, what I have done, you see, I have applied a binomial theorem to equation number 4 and omitted higher terms. I have retained terms up to first order in this equation. Then I do the same thing to equation number 5 as well, using binomial theorem. On equation number 5. So what I get this 1 upon R2 is equal to 1 upon R, then 1 plus 2a cos theta upon R. It is multiplied with the power 1 minus 1 divided by 2. Minus half. Okay. If I multiply this, what do I get? I get this 1 upon R2 is equal to 1 upon R. So here 2 and 2 get cancelled. Now minus multiplied with plus, you get minus 1 minus a cos theta divided by R. This is the value of 1 upon R2. So I box this for better visibility. I name this one as equation number 7. Equation number 7. Now I am going to use equation number 6 and 7 in equation number 3 to get the value of V. Substituting equation 6 and 7 in a tree. So what I'll get by doing so? So B equals to 1 upon 4 pi epsilon naught multiplied with Q, open bracket, 1 upon R1. The value of 1 upon R1 is taken from equation number 6. It's nothing but this flower bracket I will open. Yes. 1 upon R into 1 plus A cos theta divided by R. What is the value of 1 upon R1? Minus the value of 1 upon R2. In the place of 1 upon R2, I mentioned equation number 6. Equation number 7. So here again. On the bracket here, 1 upon R 1 minus A cos theta upon R. Okay. Now the minus is multiplied with each term. So what I'll get if I do so? First, 1 upon R1 is R is just multiplied with each term. This same thing here as well. Then this term is multiplied with this. Let's see what do we get by doing so. Equals to 1 upon 4 pi epsilon naught into Q. Now expand this. Instead of expansion, I do one easy method here. I follow one easy method. I take the common terms outside. What is the common term here? 1 upon R is present in both the things. So it is taken out. So instead of a Q, I write Q upon R. So Q is present here. 1 divided by R is taken from inside because it is common. So what remains now is 1 plus A cos theta upon R. And here minus multiplied with this, get of minus 1. The minus multiplied with minus becomes plus A cos theta upon R. Here minus 1 and the plus 1 get cancelled. And what we obtain is nothing but this. B equals to 1 upon 4 pi epsilon naught multiplied with Q upon R, and what is left inside the bracket is nothing but this, A cos theta divided by R. Then it is added with A cos theta divided by R. Now I add these two terms present within the bracket. So it is written in this manner, 1 upon 4 pi epsilon naught Q upon R, then 2 A cos theta divided by R. This is what we obtain. The next step, this term is kept as such. Now R is multiplied with this. I get Q upon R square. Then what is written inside is 2A cos theta. This can be rewritten as like this. V equals to 1 upon 4 pi epsilon naught. Written as 2a q divided by r square cos theta. This is the expression for electric potential at point P due to an electric dipole. Now we know the magnitude of charge when multiplied with the distance between the charges that constitute electric dipole provides us electric dipole moment. So 2aq is nothing but P, electric dipole moment. So I read it this way. The above equation is written in this manner. V equals to 1 upon 4 pi epsilon naught in the place of 2aq I write P. Here P stands for electric dipole moment. R square cos theta. This is the final expression for electric potential at a point P due to an electric dipole. Here I take this one as equation number 8. Actually, what is P? P is nothing but 2aq. That's why I written in this manner. Okay. Now we'll discuss a few special cases. Yeah. The first special case, special cases. Case 1. Case 1. The case 1, what I do? I take this is electric dipole. Here, point P is taken along the axis. Here, point P is taken along the axis on the side of positive charge. Yeah, there is a midpoint to go. When you do so, the angle made here is 0 degree. Here the angle is 0 degree. Now, the above equation, theta is taken as 0 degree, and the cos of theta is cos of 0, that is nothing but 1. This is known to us. If I substitute the value of cos theta in equation number 8, I will get the value of V. So, V is obtained as 1 upon 4 pi epsilon naught P upon R square multiplied with 1. So, for the first case, V value is nothing but this, V upon R square. This is the electric potential at a point taken along axial line kept near positive charge. Okay, then I go to the next case, case 2. We'll see what I do. Now I take a point P along the axial line towards the negative charge. The diagram will appear something like this. This negative charge, this is positive charge. These two constitute electric dipole, and here we have a point O. Point O. Now, point P is taken here. Point P is taken here along the axial line towards negative charge. Now the angle made is the angle, it is nothing but 180 degree. So theta is taken here as 180 degree. So theta is 180 degree. So cos of theta will become cos of 180 degree. Now what is cos of 180 degree? Cos of 180 is nothing but minus 1. That I am going to substitute in equation number 8. So what I will get? I get this V equals to 1 upon 4 pi epsilon naught P small p divided by R square. The place of cos theta, what do I have? I have minus 1. Minus 1. Okay. So the value of V is nothing but this. Minus 1 multiplied with this, we get a minus n here. Right? P upon R square. This is the expression for electric potential at point P taken along axial line towards a negative charge. Clear? Then I go to the next case. Case 3. What is this? Now, take the electric dipole. And here we have midpoint O. Now point P is taken here along the equatorial line. Yeah, along the equatorial line. Like this. When the point P is taken along equatorial line, here theta makes an angle 90 degree. Yeah, this 90 degree. You know about the angle. Nothing but perpendicular angle. This 90 degree. So when theta is taken as 90 degree, cos of theta is equal to cos of 90, and it is nothing but 0. Cos of 90 is 0. So V equals to 1 upon 4 pi epsilon naught P upon R square multiplied with 0. So what we get is nothing but this V becomes a 0 here. Okay, this is what we obtain. That box this. So this clearly shows that if you take a point P along equatorial line, then the electric potential due to electric dipole will be 0 at that particular point. Now, we discuss few important things about equation number 8. If we compare the electric potential at a point P taken along a point P due to electric dipole, this shows that V, electric potential, is found to be inversely proportional to square of R. Here, this is a constant. So V is found to be inversely proportional to R square. Whereas if you try to find out the electric potential due to a single charge, electric potential due to a point charge, then it is found to be inversely proportional to R. So by comparing these two, we find that V due to an electric dipole approaches 0 faster than electric potential due to a point charge. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put your questions in the comment section. Thanks for watching.